Hey guys, happy Wednesday. So today we're going to be talking about chapter 13, section 5, which is the cosine function. The notes for this section are a little bit shorter because a lot of the same properties that apply to sine also apply to the cosine function. So the objectives for this section are to graph and write cosine functions and to solve trigonometric equations. And the cosine function y equals cosine of theta matches theta with the x-coordinate of a point on the unit circle where the terminal side of an angle intersects the unit circle. The symmetry of sets of points x, y equal cosine theta sine theta on the unit circle guarantees that the graph of sine and cosine are congruent translations of each other. So the graph of cosine looks very similar to the graph of sine, it's just shifted a little bit. Essential understanding for this section. For each and every point along the unit circle, the radian measure of the arc has a corresponding cosine value. The colored bars represent the cosine values of the points on the circle translated onto the cosine graph. So you'll see the curve of this graph looks exactly the same as the sine function. The only difference is that it's shifted over. So we can see on this graph, we have green bars at 0 and at 2 pi. If you think about 0 and 2 pi on the unit circle, that's on the positive x-axis. That point on the positive x-axis is at 1, 0. So we know the cosine value is always 1. So these bars, the cosine of 0 is 1 on the unit circle. The cosine of 0 and the cosine of 2 pi are also 1 in the cosine graph. So this is what the cosine of x graph looks like. You'll notice without any changes in our amplitude or a period, the positive maximum value is positive 1. The negative or minimum value is negative 1. And remember, in our sine graph, the sine graph always goes through the origin. Again, if you think about the unit circle, on the positive x-axis, that's 0 and 2 pi. The point on that positive x-axis is 1, 0. So the cosine is 1 and the sine is 0. That's why our sine graph always crosses through the origin, and our cosine graph now is always going to cross the y-axis at 1 or whatever the maximum or minimum value is of the graph, depending on any transformations. There are also some other key points on this graph that we know from our unit circle, such as at 0, we're at 1, at 2 pi, we're at 1, and at negative 2 pi, we're at 1. At pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2, our cosine value is 0. And for negative pi and pi, which would be the negative x-axis, we're at negative 1. And a concept summary for the properties of cosine functions, the same as the properties for sine functions. Now we're just talking about a cosine equation rather than sine. So suppose y equals a cosine b theta with a not equal to 0, b greater than 0, and theta in radians. The absolute value of a is the amplitude of the function. B is the number of cycles in the interval from 0 to 2 pi, and 2 pi over b is the period of the function. To graph the cosine function, locate 5 points equally spaced through one cycle. For a greater than 0, this 5-point pattern is max, 0, min, 0, max. So we have a pattern, 5-point pattern again, with cosine, but now we're starting at our maximum value when a is greater than 0. So let's look at a graphing example. So it's the same exact concept as what we did when we're graphing sine functions. So sketch one cycle of y equals 1.5 cosine of 2 theta. So first, looking at this equation, we know that our amplitude is 1.5. That means our maximum point on this graph is going to be at 1.5. Minimum point on this graph is going to be at negative 1.5. The period we can find by doing 2 pi over b. In this equation, our b value is 2. So 2 pi over 2 gives us a period of pi. Now to figure out our 5 key points on this graph, we have to divide our period by 4. So pi over 4 is going to be the intervals that we mark along our theta axis. And remember, our key points are evenly spaced apart. That's why we're adding pi over 4 each time when we're marking off our axis. So we're going to start at 0. First point is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. Plus pi over 4 is 3 pi over 4. And then plus pi over 4 gives us pi. And we're doing the same thing in the negative direction. We have negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Remember, this b value tells you how many cycles we go through from 0 to 2 pi. So we're going to get through 2 cycles from 0 to 2 pi, which means we're going to get through 1 cycle from 0 to pi. So now once we have all this labeled, we can start graphing our points. Because A is positive, that means we're starting our graph at the maximum. And the maximum point on this graph is at positive 1.5. And from 1.5, for our first key point, we go to 0 following this pattern, then to the minimum, which is negative 1.5, then back to 0, and to the maximum. So here we have our 5 key points labeled. We can also graph in the negative direction following the same pattern. So we start at our maximum, our first point, we go to 0, then to negative 1.5, back to 0, and to positive 1.5. So here is our graph for this cosine function. Let's try another graphing example. Sketch one cycle of y equals negative 2 cosine of theta over 3. So again, first we can figure out our amplitude. And remember, your amplitude is the absolute value of A. So this negative in front does not change your amplitude at all. Your amplitude is always going to be positive. So our amplitude is positive 2. Which means that the maximum point on our graph is 2 and the minimum point is negative 2. This negative sign is changing our pattern. It changes our starting point on the y-axis, which we'll talk about in a second when we start graphing. Now the period, again, to find the period, we do 2 pi over b. Our b value in this case is 1 over 3. So to find our period, we're doing 2 pi over 1 over 3. We can multiply by the reciprocal, so 2 pi times 3 gives us a period of 6 pi. To find our key points for this graph, we take our period and divide by 4. So 6 pi over 4 is giving us intervals of 3 pi over 2. So now we can label our theta axis with our intervals. So for our intervals, we're going to start at 3 pi over 2 plus 3 pi over 2 gives us 6 pi over 2, which is 3 pi. Plus 3 pi over 2 is 9 pi over 2. Plus 3 pi over 2 is 6 pi. We're going to label in the negative direction as well. Negative 3 pi over 2. Negative 3 pi. Negative 9 pi over 2, and negative 6 pi. So now when we go to graph this function, because our a value is negative, that means our pattern is opposite. So because it's negative, we're going to start at our minimum. Then from the minimum, for our next key point, we go to 0, then to the maximum, which is 2, back to 0, to the minimum. So that's the right side of our graph. For the left side of our graph, we go from the minimum to 0, to the maximum, back to 0, and to the minimum. So your graph looks like this. And that's it for those two graphing problems. And before we move on to the next problem, we can take a second and interpret this graph, because we haven't talked about domain and range in a little while. So remember, domain is represented by the x values. So in this graph, and in all sine functions, your domain is going to be all real numbers. We're going to hit every x value from negative infinity to positive infinity. Your range, though, is dependent on the amplitude. So we know the range, or we know the maximum point on this graph is at positive 2, and we know the minimum point on this graph is negative 2. Our cosine curve is going to continue throughout this graph, but it's going to stay between positive 2 and negative 2 for our y values. So our range for this graph is going to be negative 2 is less than or equal to y, which is less than or equal to positive 2. So your range is dependent on your amplitude. And notice it's less than or equal to because we do have points at positive 2 and at negative 2 on this graph. For our next example, we're going to write a cosine function that is reflected over the x-axis, has an amplitude of 2/7, and a period of 3 pi. So remember, when we're writing out our cosine function, we're starting with y equals a cosine of b theta, where a is represented by our amplitude and b is the number of cycles that occur from 0 to 2 pi. So we know our amplitude is 2/7. We don't have to do any other work to figure that out. But we're also told in this problem that the cosine function is reflected over the x-axis. We symbolize a reflection over the x-axis with a negative. So in front of our amplitude, we're going to have this negative symbol, which means that we're starting at the minimum rather than the maximum. That's our reflection. So it's going to be negative 2/7 cosine and theta. So the only thing that we're missing is this b value. And to find this b value, we're going to use the period. So we know the period is represented by 2 pi over b. So here's where we have our b. That's how we're going to figure it out. The period of this function is 3 pi. So 2 pi over b equals 3 pi. We'll put it over 1 so we can cross multiply. Now when we cross multiply, when we cross multiply, we get 2 pi equals 3 pi times b. So to solve for b, we're going to divide both sides by 3 pi. 2 pi over 3 pi gives us a b value of 2/3. So our b value for this function is 2/3, which makes the cosine function written out fully y equals negative 2/7 cosine of 2/3 theta. And now for the last type of example for this section, modeling with a cosine function. So the last example is going to be a word problem. So the water level varies from low tide to high tide as shown. What is a cosine function that models the water level in inches above and below the average water level? Express the model as a function of time in hours since 10:30 a.m. So we can see from this diagram, we have a couple things. Low tide at 10:30 a.m. is this water level here, and high tide at 4:40 p.m. is 60 inches higher than the low tide. So we're going to call low tide in this case 0 so that we can give high tide a value of 60 inches. Using these values, we can figure out the amplitude of this function by doing 60 minus 0/2. So the amplitude in this case is going to be 60/2, which is 30. So the amplitude for this function is 30. We also know, looking at the diagram, that low tide occurs at 10:30 a.m. and high tide occurs at 4:40 p.m. So from low tide to high tide, 6 hours and 10 minutes have elapsed. Now, if we think about the tides as a function, that means low tide is the minimum and high tide is our maximum value. So this time, 6 hours and 10 minutes, only represents half a cycle. Remember, the cycle has to begin and end at the same exact spot. So from the minimum to the maximum, that's just half our cycle. So half our cycle is represented by 6 hours and 10 minutes, which means that one full cycle can be represented by 12 hours and 20 minutes. So to go from low tide to high tide back to low tide, that's going to be 12 hours and 20 minutes. 12 hours and 20 minutes, though, doesn't really help us when we're trying to plug into our equation. So we're going to write this as a mixed number. So 12 hours, 20 minutes out of 60 minutes gives us a fraction of 1/3. So 12 1/3 is going to be the period of this function. Now to write out our function, to express this model as a function, we have our period, we have our amplitude, now we have to figure out our b value. And again, to figure out our b value, we're going to use the period. So our period is represented as 2 pi over b, and the period of this model is 12 1/3. So if I write that as an improper fraction, that's going to be 37/3. Now to figure out our b value, we're going to cross multiply. So we have 6 pi equals 37b. Now to solve for b, we're just going to divide both sides by 37. So b equals 6 pi over 37. So now we have everything that we need to fill out and to create our function. So our function is going to be y equals, our amplitude is 30, cosine of 6 pi over 37 theta. So now we have our amplitude and we have our b value, but there's one other thing that we can't forget to take into consideration. So for this model, it's modeling our tides from low tide to high tide. Low tide to high tide, which means that this graph is starting at the minimum value and then going to the maximum value. Anytime you have a cosine function where you're starting at the minimum value, that means that there's a reflection over the x-axis, which tells you that there has to be a negative a value. So anytime you're starting your graph at the minimum, your a value is always negative. So you'll have to, don't forget to take that into consideration. So our final function for this model is going to be y equals negative 30 cosine of 6 pi over 37 theta. And that's it for this section. If you have any questions, please feel free to reach out to me. Your homework is posted to Google Classroom. Good luck.